Hello dear students, today we are going to start with the increasing decreasing functions. Okay, before discussing the increasing decreasing function topic, what is mean by slope? Any inclination or any declination, we call it as a slope, right? Let us consider this is a line inclination, right? And this line is a declination. Now let us consider this is inclination, slope is always positive. Okay, declination always negative, and slope of a line which is parallel to x-axis is always 0. Okay, slope of a line which is parallel to y-axis is infinity because it is making an angle 90 degrees, right, with respect to x-axis. So let us consider slope is what? M is equals to tan theta, m is equals to tan 90 degrees, so it is infinity. Okay, so here slope is what? Dy by dx. We can write it as a differentiation of the function f dash of x, or else tan theta, right? So here slope of a line f dash of x is positive. Slope of a line, inclination of a line is positive. Declination of a line, slope is negative. Okay, slope of a line parallel to x-axis f dash of x is 0. Slope of a line y-axis parallel to y-axis is f dash of x is infinity. Okay, let us consider one curve. This is x-axis, y-axis. If I draw a tangent, it will gives you the slope. Okay, it will gives you the slope which is f dash of x. This is inclination, right? Positive. F dash of x is positive means what? F dash of x is positive means what? F dash of x is greater than 0. Okay, so if I draw a tangent here, it is also positive. F dash of x is positive because inclination, right, not declination. If I draw a tangent at middle, uh, this is f dash of x is slope is 0. So from here we can see here slope is either greater than 0 or equals to 0. So therefore this is what is the condition? Increasing condition. Okay, this is increasing condition. This is increasing function condition. Okay, next let us consider curve x-axis, y-axis. Let us consider this is a curve. Okay, if I draw a tangent at every point on a curve, I can get what? Positive slope, right? F dash of x is greater than 0. F dash of x is greater than 0. But I can't able to get equals to 0, right? So f dash of x is greater than 0, which is a strictly increasing function. Strictly increasing function. Next, let us consider one more, x-axis, y-axis. This is let us draw a tangent here. If I draw a tangent, it is downward direction. It is a tangent declination, right? Slope is negative. Means less than 0. And if I draw a tangent here, slope is what? Slope is equals to 0. Therefore we can write all together conditions. F dash of x is less than or equals to 0. So we can call it as a decreasing function. Okay, this is a decreasing function condition. Next, let us consider curve x-axis, y-axis. This is a curve. Okay, if I draw a tangent here, this is downward direction, declination, right? Declination at every point on a curve. It will gives you, if I draw a tangent at certain points on a curve, it will gives you declination, right? Declination is slope. Slope is negative. Means f dash of x is less than 0. Here also f dash of x is less than 0. f dash of x is less than 0. Say we can say this function is a strictly decreasing function. Strictly decreasing function. So here these are the conditions. Increasing condition is f dash of x is greater than or equals to 0. Strictly increasing condition is f dash of x is greater than 0. And decreasing function is f dash of x is less than or equals to 0, and f dash of x is less than 0 for strictly decreasing function. Okay, these are the conditions. Make a note of it. We will start with the exercise problem. Okay, here we have a first question. Show that the function f of x is equals to 3x plus 17 is increasing on real number. So what is given? First write the given function. Okay, given function f of x is equals to 3x plus 17. Next step is differentiation. Okay, differentiate with respective x on both sides. So differentiation of f of x is f dash of x is equals to differentiation of 3 into x plus differentiation of 17. Okay, f dash of x is equals to, here differentiation formula, differentiation of x is always 1. Okay, differentiation of x is always 1. So substitute. Now this is constant, don't differentiate 3. If we have multiple to the variable, so 3 outside, differentiate the x. Differentiation of x is 1 plus differentiation of constant is 0. Okay, differentiation of constant is always equals to 0. So this is 0. F dash of x is 3. Therefore f dash of x is what? Greater than 0. Positive, right? Greater than 0. So f dash of x is greater than 0 means given function is strictly increasing on real number. That's all. This is the solution. Okay, this is the solution. Second question, show that the function f of x is equals to e to the power of 2x is increasing on real number. So given function, first we will write given function f of x is equals to e to the power of 2x. Now differentiate the function, differentiate with respective x. Okay, on both sides. So differentiation of f of x is f dash of x is equals to differentiation of e to the power of 2x. So differentiation of e to the power of f of x is e to the power of f of x, and differentiation of f of x f dash of x. Okay, this is the formula. So here differentiation of e to the power of x is e to the power of x, like e to the power of 2x we have, so e to the power of 2x. Again differentiation of e to 2 to the power of x, chain rule. Okay, 2 to the power of x. Here we have a constant outside. Differentiation of x is always equals to 1. Okay, differentiation of x is always equals to 1. In the previous problem I said already. So e to the power of 2x into differentiation of x is 1. So constant we will never differentiate when we have a multiple to the variable. Okay, this is 2 into 1. So therefore 2 into e to the power of 2x. In general f dash of x is equals to 2 e to the power of 2x. So in general e value is 2.718 and so on. Okay, so which is basically lies from 2 to 3. E lies from 2 to 3, and always e value is positive. E value is positive. If I multiply 2 to the e, then it will become 4, right? 2 2 is a 4 point something. If a variable, if x is variable negative, then it will decreases, but even though it is x values decreases, but it will end up with a positive. Okay, always this e value is positive. Positive into 2 is always positive, therefore greater than 0. So hence we can say this is strictly increasing on a real number. So f of x is strictly increasing increasing on real number. That's all. This is the solution. Here we have a third question. Show the function given by f of x is equal. So given function. First write given function. Given function f of x is equals to sine x. Okay, sine x. Differentiate with respect to x. Differentiate with respect to x on both sides. On both sides. So differentiation of sine x is always as cos x. Remember. Okay. This is cos x. So this is the formula. So f dash of x is equals to sin x differentiation is cos x. So cos x. Now what is asking in the first bit, increasing, we have to show, now prove this, increasing in 0 to pi by 2. So he is saying that he is asking to prove function is increasing from 0 to pi by 2. Here 0 to pi by 2, this is 0. Here 0 to pi by 2, okay. 0 to pi by 2 comes into first quadrant, right, first quadrant, and therefore we can say that 0 to pi by 2, that means 0 to pi by 2 first quadrant, 0 to pi by 2 belongs to first quadrant. In first quadrant all positive, right, all positive, cos x is positive, so here cos x is greater than 0 in quadrant 1. So therefore we can say f dash of x is equals to cos x. Here we have f dash of x is equals cos x. Cos x is positive in first quadrant, therefore we can say f dash of x is greater than 0, and this is increasing, strictly increasing function. Okay, this is increasing function. Increasing function. This is increasing function. Next, decreasing in pi by 2 to pi. Next, decreasing pi by 2 to pi. So here this is pi by 2 and this is pi. So here pi by 2 to pi belongs to second quadrant. Okay, belongs to second quadrant. In second quadrant, what are positives? First of all, we will write the slope. What is slope? F dash of x is equals to cos x. But in the second quadrant, sine positive and cosecant positive. Sine positive, cosecant positive. Remaining all are negative. Therefore, cos x is less than 0. Therefore, we can say f dash of x is less than 0. So here slope is less than 0 means decreasing. Okay, decreasing pi by 2 to pi. Okay, decreasing function in interval of pi by 2 to pi. Next, what is asking? Here 0 to pi by 2 function is increasing. 0 to pi by 2 function is increasing. Pi by 2 to pi function is decreasing. So overall together, if we consider 0 to pi, then function neither be increasing nor decreasing. Function is neither increasing nor decreasing. That's all. This is the solution. First, given function differentiated, we got the slope. Now we are checking 0 to pi by 2, slope is positive or negative. So in the first quadrant, slope is positive because cos x is positive. In the second quadrant, cos x is negative. In the second quadrant, like in second quadrant, cos is negative. So due to which slope is negative. Slope is negative means a decreasing function. Therefore 0 to pi by 2 increasing, pi by 2 to pi decreasing. Therefore 0 to pi overall is function is neither increasing nor decreasing. That's all. This is the solution. Next, Here we have a question, find the intervals in which the function is given by f of x is equals to 2x cube minus 3x square minus 36x plus 7 is increasing, decreasing. He is asking find intervals. Whenever you encounter with the intervals kind of question, first differentiate, make it equals to 0 and find the critical points. Then later on just plot on a number line, you can get increasing, decreasing function intervals. Okay. Now first given function, we'll write given function f of x is equals to 2x cube minus 3x square minus 36x plus 7. Okay. Now differentiate with respective x. Okay. So f dash of x is equals to, first step is differentiation of differentiation of x to the power of n is n into x to the power of n minus 1. Okay. So follow this formula. Differentiation of x cube 2 into differentiation of x cube minus 3 into differentiation of x square minus 36 into differentiation of x plus differentiation of 7. Okay. F dash of x is equals to, differentiation of x cube is 3x square minus 3 into x square differentiation is 2x minus 36 into x differentiation is 1 plus constant differentiation is 0. Therefore f dash of x is equals to, take common, 2 3 is 6, 2 3 is 6, 6 6 is 36, so take common 6. Okay. Then x square minus x minus 6. Okay. Therefore we can say here slope is f dash of x is equals to 6 times of x square minus x minus 6. Can we able to split this middle term here? 3 2 is 6. So x square minus 3x plus 2x, 3x minus 6. So 6 into x take common, x take common. So x minus 3. Take 2 common, x minus 3. Therefore 6 into x minus 3 take common, and here x plus 2 remaining is x plus 2. So we have f dash of x is equals to this. Now we found the f dash slope. Okay, now we found slope. Let the slope be, make it equals to 0. Let slope is equals to 0. So 6 times of x minus 3 into x plus 2 equals to 0. And then either x minus 3 is equals to 0 or x plus 2 equals to 0. So x is equals to, send 3 to the right hand side, plus 3, or x is equals to minus 2. Okay, minus 2. So these are the critical points. We make f dash of x is equals to 0 to find critical points. Critical points. So here number line. This is a 3 and this is minus 2. Okay. This is infinity, this is minus infinity. Now what we have, f dash of x is considered. What we have, slope f dash of x. F dash of x is 6 times of x minus 3 into x minus x plus 2, x plus 2. Let us consider any number in between 3 to infinity. I am considering 4. Okay. F dash of 4 is equals to 6 times of, I am substituting randomly, 3 to 4, random number 4. 4 minus 3 is 4 minus 3 is 1. Okay, 4 plus 2 is 6. So positive, everything is positive, right? This is greater than 0, positive. Therefore this is positive. Okay, 3 to infinity, positive slope. Next, consider any number from minus 2 to 3. Let us consider 0. So I am substituting in the slope. In the place of x I am substituting 0. 6 into 0 minus 3, minus 3, and 0 plus 2 is how much? 2. Okay, so therefore here you are getting negative, right? Negative into positive, positive, negative into positive, negative, negative into positive, negative, therefore negative. So here negative sign you are getting. That means f dash of 0 is less than 0, means less than 0 means negative. Next, minus 2 to minus infinity. Consider any number. Okay, let us consider f dash of let us consider minus 3. So minus 3 lies from minus 2 to minus infinity. So I'm considering minus 3, 6 times of, in the place of x I'm substituting minus 3, in the place of x minus 3 plus 2. Okay, so 6 times of, this is minus 6, and this is minus 3 plus 2, minus 1. So minus into minus plus, therefore f dash of minus 3 is greater than 0, positive. Our main intention is to find the signs, whether this is positive or negative slope. So these are the slopes, slope values. Okay, so here positive, negative, positive. What is asking? Is asking to find the interval of increasing function, right? So here I am writing the increasing function, increasing interval. Okay, increasing function interval. Mine increasing means positive, right? Slope is positive. This is also positive. So can I write minus infinity to minus 2 slope? So x belongs to minus infinity to minus 2. Here we are including minus 2 here. Next, 3 to infinity, union 3 to, including 3 and infinity we are not including. So this is increasing function. Next is strictly increasing function. Strictly increasing function is x belongs to minus infinity to minus 2, but this is not we are including. Minus 2 we are not including this. Okay, and 3 we are not including infinity. This is strictly increasing. Next, decreasing function. Decreasing condition is here. Negative slope gives you decreasing. So interval is minus 2 to 3. So x belongs to minus 2 to 3. So this is including minus 2 and 3 is including. Okay, and strictly decreasing is x belongs to minus 2 comma 3. Therefore these are the results of intervals. At what interval the function is increasing means x belongs to minus infinity to minus 2, this including 2 and including 3 to infinity. Okay, so next, strictly increasing we are not including 2 here, not including 3. Decreasing function we are including minus 2 and 3, and between the values we including. Strictly decreasing means we are not including extreme values minus 2 and 3. Is this clear? That's all. This is the solution. Let me zoom out and check out the procedure. Okay, first function, differentiate the function, simplify the function, make it equals to find the critical points. After getting critical points, just plot on a number line and check the slope whether the positive or negative. We got by using trial and error method, positive, negative, positive. Therefore if a slope is positive means increasing, if a slope is positive means increasing, if a slope is negative means decreasing. So positive slope we have increasing condition is I wrote here. Strictly increasing and increasing, I hope you got a difference between those two, right? Decreasing and strictly decreasing, you got a difference between those two. Here in decreasing we are including the extreme values, in strictly decreasing we are not including extreme values. Okay, that's all. This is the solution, and remaining problems are homework, consider as a homework. Okay, here we have a question 7th. Show that the y is equals to log of 1 plus x minus 2x by 2 plus x. So we have to prove x is greater than minus 1 increasing function of x throughout its domain. Okay, let us consider given function, given y is equals to log of 1 plus x minus 2x by 2 plus x. So first step is what? Differentiation, right? Differentiate with respective x, differentiate with respect to x, then it will be a dy by dx is equals to d by dx of log of 1 plus x minus 2 into d by dx of x by 2 plus x, x by 2 plus x. So here we know differentiation formula. Differentiation of log x is what? Differentiation of log x is 1 by x. Okay, differentiation of log x is 1 by x. Differentiation of u by v, u by v can be written as v differentiation of u minus u differentiation of v by v square. Okay, this is the differentiation of u by v. Just do follow this formula. Okay, now dy by dx is equals to differentiation of log x is 1 by x. So this is again differentiation. Differentiation of 1 is 0. Differentiation of constant x is 1. So 0 plus 1 minus 2 into differentiation of u by v, this is okay, u by v. V is x 2 plus x. Differentiation of x is 1 minus v u dash plus, so here v u dash minus u v dash, u differentiation of 2 is 0, x differentiation is 1 by v square 2 plus x whole square. Okay, now dy by dx is equals to 1 by 1 plus x minus 2 into 2 plus x minus x, 2 plus x in minus x by 2 plus x whole square. So here plus minus cancel, plus x minus x cancel. Therefore we can write dy by dx is equals to 1 by 1 plus x minus 2 into, this is 2 by 2 plus x whole square. Right, now take LCM, dy by dx is equals LCM 1 plus x into 2 plus x whole square, 2 plus x whole square. So remaining is 1 plus x cancel, then remaining is this term into 1, it's 2 plus x whole square minus 2 2s are 4 into 2 plus x whole square, 2 plus x whole square cancel, remaining is 1 plus x into 4, this is 1 plus x. Okay, so dy by dx is equals to difference a plus b whole square, 2 square, a plus b whole square, 2 square is a plus b whole square, formula is a square plus 2ab plus b square. This is the formula. So I am applying here formula. A square is 2 square 4 plus 2ab, 2 2s are 4 into x, 4x plus b square is x square minus 4 into 1 minus 4 minus 4 into x minus 4x. Okay, minus 4 into 1 minus 4 minus 4 into x minus 4x minus 4x divided by 1 plus x into 2 plus x whole square. So from here plus 4 minus 4 cancel, plus 4x minus 4x cancel, dy by dx is equals to x square by 1 plus x 2 plus x whole square. So therefore here x square is x square means if you substitute any values it will be greater than 0, right, and 2 plus x whole square is also greater than 0, and in order to make it is a increasing function, slope is positive. In order to make it positive, definitely 1 plus x should be greater than 0, right? To make slope positive, 1 plus x should be greater than 0, then only it will be a slope is positive. Therefore we can say this is increasing function. So therefore subtract both sides by x 1, so minus 1 plus x greater than minus 1, so plus x minus x cancel, x is greater than minus 1. So at this condition it is increasing function, therefore we proved, and therefore increasing function at a domain of x is greater than minus 1, x is greater than minus 1 is a domain of increasing function. Okay, so x minus 1 is the increasing function of x throughout its domain. So x minus x is greater than minus 1 is a increasing function, throughout its domain. Okay, throughout its domain. Once again, given question, differentiate the function. We got the result. We got the result, and we got the results x square by 1 plus x into 2 plus x whole square. So x square means positive, 2 plus x is also positive, whole square is there. So 1 plus x need to be positive in order to get slope is positive, in order to get slope positive. So slope is in order to make it positive, we are making a 1 plus is greater than 0. Therefore is greater than 0 means we can get x is greater than minus 1 is a increasing function throughout its domain. That's all. This is the proving part, hence we done. Is this clear? Here we have a question. Find the value of x for which which function y is equals to x into x minus 2 overall square is increasing function. Now given, what is given we will write first. Given function is y is equals to x into x minus 2 whole square. Now first we will just do simplification. X multiply inside, x into x square, x into 2 minus 2x whole square. Okay, now what is asking? Find the values of x for which the values. So first what we'll do, differentiate with respect to x. Differentiate with respective x. So dy by dx is equals to differentiation of x square minus 2x whole square. Okay, differentiation of a function whole to the power of n can be written as n into f of x whole to the power of n minus 1 into differentiation of f of x. Okay, differentiation of f of x. So this is the formula we are following now. So here apply the formula. 2 into x square minus 2x whole to the power of 2 minus 1 inside differentiation. Differentiation of x square minus 2x. 2 into x square minus 2x. Differentiation of x square is 2x. Differentiation of x is 1. So 2. Therefore we can write it as 2 2's. 2 take common. 2 2's are 4. X square minus 2x into x minus 1. And one more. Here take x common. 4 into x. X minus 2 into x minus 1. Therefore this is what dy by dx. So what is asking? Find x value, right? Find the value of x for which it is increasing function. So here same, finding interval for increasing function. Let slope be 0. Let dy by dx is equals to 0 to find critical points. To find critical points. Critical points. So dy by dx is 4 into x minus 2 into x minus 1 equals to 0. Therefore either x is equals to 0 or x minus 2 equals to 0 or x minus 1 is equals to 0. So send this 2 to the right hand side, it will become plus 2. And minus 1 send it to the right hand side, it will become plus 1. Therefore plot on number line. This is 2 and this is 1. This is 0. Okay. Consider this is infinity. This is minus infinity. We have a slope. What is the slope? Dy by dx is 4 times of x into x minus 2 into x minus 1. X minus 1, right? X minus 1. So consider any number randomly from 2 to infinity. 2 to infinity, consider 3. So if I substitute dy by dx at x is equals to 3, then this is 4 into 3 and this 3 minus 2. 3 minus 2 is 1. 3 minus 1 is 2. Hence there is this is greater than 0. This is greater than 0. This is positive. Next, 1 to 2, consider any number. 1 to 2. Let us say 1.5. 1.5. Dy by dx at x is equals to 1.5. Then this is 4 into 1.5 into this is 1.5 minus 2 is minus 0.5 and this is 1.5. 1.5 minus 1 minus 1.5 minus 1 is 1.5 minus 5 is 0.5, right? Plus 0.5. This is plus, this is minus. Overall is less than 0. Overall is less than 0. This is negative. And substitute any, consider 0 to 1 any number. So consider at x is equals to 0.5. So 0.5 substitute in slope. Okay, 4 into 0.5, and this is 0.5 minus 2 is minus 1.5, and this 0.5 minus 1 is minus 0.5. So minus into minus plus, overall is greater than 0. So this is plus. And 0 to minus infinity, consider any number, negative number. Let us consider dy by dx at x is equals to minus 1. So minus 1 consider, 4 into minus 1 into minus 1 minus 1 minus 2, minus 1 minus 2, minus 1 minus 2 is minus 3. Next, minus 1 minus 1 minus 2. So minus into minus, minus into minus, plus, plus into minus is minus. Okay, so less than 0. Therefore, we can say this is a negative. So from here we can say this is increasing function. Increasing function intervals I am writing. Listen carefully. Increasing function. Increasing interval is x belongs to. Here positive, we will consider positive. Okay, 0 to increasing, 0 to 1, close brackets, union, 2 to infinity, 2 to infinity. This is increasing function. Strictly increasing function, x belongs to 0 comma 1, open brackets, union, 2 to infinity. Next, decreasing function. Decreasing function is minus infinity to 0, x belongs to minus infinity to 0. 0 is including because it is decreasing. Okay, decreasing function. Next, union, 1 to infinity, 1 to 2, 1 to 2. So this is decreasing. In the question, he asked this question. So this is a solution. If he will ask you to find interval of strictly increasing, this is a solution. These are the two additional solutions in order to make you understand. Okay, that's all for today. This is the solution. First function, simplify it, differentiate it and make it equals to 0. In order to find a critical points, we got a critical points and we substituted random numbers in that in order to find the slope. So we got it, the slope positive, negative, positive. Therefore, we concluded that increasing function is from 0 to 1 and 2 to infinity. This is a solution for the given question, and additional solutions are these are decreasing, strictly increasing. Okay, that's all. Thank you.